Isn't that already?
Yeah. I think the pen's died.
Oh, that's weird. Usually have pens everywhere. Let's do this one. This one I know is good. It's a felt tip, but it'll do just fine.
Wow, these are really. You have like a collection going on?
I'm almost out. I need to buy new ones. I use them up.
Yeah, I'm good. I'm over 18.
Yeah, so you're good to go there, right?
Mm-hmm.
Yay! Alright, so you ready to have some fun?
Mm-hmm.
So here's what's gonna happen. I'm just gonna throw some tasks out there and ask you some questions. Again, you just write what you want. You'll notice that the video camera is mostly focused on this.
Mm-hmm.
So if we get your face in there, it'll just be incidental.
Okay.
Right? So the goal is to just do this part and hear what you're saying. Does that make sense?
Yes.
Alright, let's rock and roll.
Mm-hmm.
So here we go. Here's a piece of graph paper.
Mhm.
I don't know what kind of pencil you like, whether you like mechanical or the other kind.
Let's go traditional.
I
I don't get many opportunities to use it, so nice one.
Yeah, it's one of my, I really prefer it overall.
Okay.
Alright, could you plot a point on that graph for me, please?
Just any point?
Any point you like.
Okay. I'm just gonna plot here.
Okay. Can you label it with the coordinates?
Sure. Since there's 10 here, there's about 1, 2, 3, 4, 5, 6, 7, 8, 9 tick marks behind it, so I can assume that the scale is not anything else besides just ones. So I'm going to say that's going to be 2, and since that's the same for the y-axis, I'm going to say that's going to be 2, 1.
Okay. And so, what
Oh, right. Never mind, it's 2, 2.
2, 2? Okay.
I made a mistake right there, not making sure and checking it. So it's 2, 2.
Alright. Can you tell me what the coordinates 2, 2 mean?
The coordinates 2, 2 means that when you're graphing on a coordinate plane, you have 4 quadrants. You have in the top right quadrant 1, over here quadrant 2, quadrant 3, and quadrant 4. Quadrant 1 is where all positive x coordinates and all positive y coordinates are going to be. In the second quadrant, it's where all positive y coordinates are going to be, but negative x coordinates. Over in quadrant 3, you'll have negative x-axis coordinates, and you'll have negative y-axis coordinates as well. And over in quadrant 4, you'll have a positive x-axis coordinate and a negative y-axis coordinate. So in this case, 2, 2 means on a grid of a coordinate plane, in quadrant 1 where positive points meet, if you go to 2 on the x-axis and you go to 2 on the y-axis, you'll find the point that I plotted.
Cool. Will you plot a second point for me then?
Okay. Plot a point there.
And we'll go ahead and label it?
Same thing as before, but this time I did about 5. It's not. I'm not doing it intentionally, but I ended up doing.
But you ended up like that with the same values?
Mm-hmm.
No worries. So if I said I'm thinking of a graph and it has a constant rate of change, could you show me that graph that goes through those 2 points?
Yes. It's just kind of be like that, a little bit more straighter than I could make it. And I could draw the line out, but for the sake, I'll just extend the arrows just to show that because of the ongoing constant graph, it's going to keep going past the current point that I plotted.
Okay. Could you tell me why that has a constant rate of change? Why that graph has a constant rate of change?
As a constant rate of change, actually I'm not able to articulate as well as I want to, but the idea is that what I know to be true is that when you want to show constant rate of change, you show through linearity, and linearity means when you graph 2 points and you can draw a straight line through it.
Okay. So does the so you're saying you couldn't articulate it well?
Mm-hmm.
Was there anything else that you were thinking about when you wrote it, when you drew the line?
Another thing that I was thinking of though were in rate of change, I always go back to the slope formula, not the slope intercept formula, but finding out the slope mean rate in a an equation like this.
Mm-hmm. So, what does slope mean? You were saying rate and slope, do they mean the same thing to you?
Slope is, I believe so, slope is the rate, and for the sake, from my memory, it also means the rate of change.
Okay.
Slope is basically this point where it's trying to say if you go over here a certain amount of times, you go up that amount of times and you do that the same, you'll get to the point where you want to. So in this case, if you go over 1, 2, 3, if you go over 3 and then up 1, 2, 3, so that means it's a slope of 3 over 3 or just 1. And then you'll meet the point where I applied before, and if you do this again, go over 1, 2, 3 and move up 1, 2, 3, you'll end up at this point, and then you'll also hit the line there.
Okay. So you said slope. So the rate of change on here has a value?
Mm-hmm.
And what's that value?
Because I moved over 3 and went up 3,
Mm-hmm.
where the top stands for moving up and the denominator stands for moving left or right. In this case, slope 3 over 3 is 1.
Okay. So you have a value for that. So could you determine? You said you determined coordinates by going this way.
Mm-hmm.
Or is there any other way to determine coordinates on that line?
Yes. If it's in a position where you're not able to just count because it might be really large scaled or so, you just look at the coordinates and you use the equation where you do y2 minus y1 over x2 minus x1, where the y2 corresponds to the latest point that you have on the y-axis,
Mm-hmm.
and y1 referring to the point that you had before on the y-axis. So if you do this out, meaning 5 minus y1, y2 minus y1, so 5 minus 2
Mm-hmm.
over 5 minus 2 because they're the same. You'll get 5 minus 2 is 3, 5 minus 2 is 3, and you'll get the same thing. And then knowing that, then you'll know the slope is just 1. And I actually don't remember what the 1 corresponds to. I know what this means, so in a fraction sense it's easier for me to understand, because in a fraction sense I'll know that on the denominator, when we're talking about rate of change, the denominator denotes it moving horizontally, whereas the numerator means to move vertically.
Okay. So you said a fraction. Does the 1, could you write the 1 as a fraction?
Yeah, you could put the 1 as 1 over 1.
Okay. Would that have the same meaning for you?
Not necessarily, because then if we go off of this, it would mean that if you move over 1, then you can move up 1.
Mm-hmm.
And okay, never mind, it does allow that. So I guess in this case, I just found out that the slope can be either or.
Okay.
So looking at this, then you could probably even do over 1, up 1, and end up on the point as well. So like over here, if I move up 1 and then move over 1 and then move up 1, I'll still end up hitting the graph. So I guess you have some options and to get to the points where you wanted to.
You wanted to? So is that the only way to determine points on the line?
Yeah, so far I think those are my 2 methods that I remember.
Okay. Could you write an equation for this line?
Yes. Graph is going to be denoted as f of x, because the mother function of a linear equation is f of x is equal to mx plus b. X is always going to be a variable that you can always have something change. So, and m we established is going to be slope. So far the pieces that we have is 1x or 3 over 3x, or you can just leave it as 1x, which usually wouldn't happen, but the slope is 1 and m is slope, so that's why I'm doing that. And b is the y-intercept. Right here we only have y-intercept. We can usually find it by, we can look it on the graph. In this case our y-intercept is going to be 0 because that's the only place where the line will hit. If we go in this direction, drawing a straight line, it'll only hit 0, so the y-intercept is 0. So in this graph is actually just a slope of 1x plus 0. Another way you can also look for the y-intercept is by doing some algebraic operations to figure out the b value.
Okay. Could you do 2 more points and see if you could find it showing me how you did the b value?
Okay. You want me to find another point?
That's okay. I was just curious about that one. We'll do it as a separate question. We'll
Okay.
finish with this one, right?
Okay.
So when you have that equation that you wrote, what do you use it for?
You can use it to graph, because now using the set of points that you kind of had to begin with, now you can kind of like extrapolate, so you don't have to continuously do count your points to get over. Now that you have an equation, you can plug it into a calculator or any sort of machine and it graphs the rest of it, and then any point you can use that to look at various other points in that line if you wanted to.
Mm-hmm. Mm-hmm. Okay. So when you calculated, show me how you can calculate, what would you do?
Okay. Calculate for b value?
Not for your b.
Oh.
So you have your equation, right?
Mm-hmm.
So you just described to me what you could do with the equation. I was wondering if you could show me what you were talking about.
Okay. I can show you on the calculator here.
Okay.
So what I can do is, this is actually a more simpler linear equation than a lot of times you're going to see it. But slope is going to be 1. There's the y-intercept is 0, so necessarily you're kind of only graphing for x.
Okay.
I see the window is kind of not fixed yet, so what I do when using my calculator is I always go to zoom standard.
Mm-hmm.
And there you go. And I also want to and whenever I do these sort of things, I want to verify if I have the right equation with the right points. So what I also do is I always check the table to see if the points match up. Here you have 0, 0. I'm sorry. I had to move up there. See, you have 0, 0, 0 here. You have 2, 2 there, and then you have 5, 5. So knowing these points match up with my table, I know that I have the right equation. And now that I have this graph, I'm free to do whatever I want with it. So if someone tells me they want a point at 100, then I can either go into the table or set the table to start at 100 or so. And I can go here and then I'll check the y value to see 100, 100 to find where I want a certain point on the grid.
Okay. And is there anything in between? Are there points in between the ones that you're representing on the table?
Yes, I believe so. Because what the line also denotes is that it just as it's graphed and it goes from negative infinity to positive infinity, there will be points that it hits, not necessarily ones that we care about, but there will be points that it hits. So like for example here, we didn't have to we didn't put a point there, but right there we can see down here, that's going to be 4, so this could be 4, 4. So that's an example.
Okay, alright. So you were talking about other ones. I'm going to ask if you can I'm going to pick the 2 points this
Okay.
time, okay?
Sure thing.
Let's see, how about, I'm going to do this one and this one. Actually, let's do that one. Alright, so here we have these 2 points.
Mm-hmm.
So tell me about how you could go ahead and draw the constant rate of change graph, if you would, through the 2 points.
Okay. Since the point's a little bit farther for my sake, I want another point. So what I'm gonna do is I'm gonna figure out the graph from this first, or find the equation from this first. So same deal as before. I'm counting to make sure everything scales up to 10. It's not necessarily counting in 2s or 5s. And since there's 9 tick marks before the 10, I'm gonna assume then that this is going to be 2. Okay, so there's a little thing that you threw in there. I just noticed. Okay, so here this is gonna be a little bit different because right on the previous one where you can hit the grid point itself, this time since it's in the middle, it could really be anything. It's up to subjective perspective. But I think for my sake, I'm gonna say this is gonna be something 0.5. In this case, on the y-axis, I have 1, 2, 3, 4, 5, 6, and 7 is the next tick mark afterwards. So because it's in between 6 and 7, I'm going to say that's going to be 6.5 for the y-axis. And specifically, since we're going down here, this is going to be negative 6.5. So the point here is going to be 2, negative 6.5. And over here, since I'm heading backwards to negative infinity on the x-axis, I have 1, 2, 3, 4. So this is going to be negative 4 on the x-axis coordinate, and on the y-axis, I have 1, 2, 3, 4, 5, 6. Just positive 6. So my 2 points are negative 4, positive 6, and 2, comma, negative 6.5.
Okay. So, do you want a ruler?
Yeah, maybe. I think I'm here. And so I want to start drawing the line just to know where we're kind of heading.
And what's the constant rate of change for that line?
To find the constant rate of change for this line, I'm going to do the same thing I did here before, which was y2 minus y1 over x2 minus x1. y2 in this case being negative 6.5. Because I just use this sort of method because when you're reading a graph, you tend to go from left to right. So in my case, I would count this as the more latest point on the graph. So then that I would count this as my y2, and therefore this would be my y1. So I do here negative 6.5 minus 6. And on the bottom, I would have 2 minus negative 4. I like to put parentheses around my integers so I won't confuse it. And I tend to go to my calculator, even though these are calculations that I could do by hand, just to be more accurate, and also I'm not too great at my mental math. So on the top I have negative 12.5, and on the bottom I have 2 minus negative 4. That's 6. So my slope in this case would be going over 6 and then going, this whole thing is going to be negative 12.5 over 6. So that means as I go backwards 6, I go up 12 and a half, and I'll get to where I need to be. And since it's going to be harder to graph there, I can just kind of go by the x-axis for now. So I have 1, 2, 3, 4, 5, 6. And as I see there, hang on, I might miscount. 1, 2, 3, 4, 5, 6. I can see that if I line this, it kind of hits where I need to. And so assuming that is correct, that means I can go up 12 and a half units upwards, and I'll also reach that point as well. I can also simplify it. No, I can't. I'll just leave it as that. So the slope here, or the rate of change is negative 12.5 over 6, meaning if you go in the horizontally 6 units over, and if you go and then you go up 12.5 units vertically, then you'll be able to get one of the points on the line.
Okay. Alright, so you would use the slope to get the other points on the line like the last one?
Mhm.
Alright, and can you write an equation for this one?
Yes, yeah. So same thing as before, since we're still dealing with linear functions, I'm going to set this up as f of x equals mx plus b, m being slope, and we have our slope here. So I do f of x is equal to negative 12.5 over 6x plus b. Now in this case, I don't exactly know where my y-intercept is. By eye, I could look at it and then probably see right there that is 2, but that's not entirely reliable. So what I do now is I can solve for b. I just choose any of the y-coordinates because f of x is also equivalent or could be read as a y-coordinate. So in this case, I'm just going to use 6 as my y-coordinate. But because I use 6 as my y-coordinate, I'll also have to use the x that corresponds with that. So in this case, that'd be negative 4. Because ultimately when you're graphing, the points need to match up with what you're trying to graph. So now that I have this, I can just start to solve it. This is 12.5 divided by 6. I need to get rid of that first. Alternatively, what I can also do is just make my life simpler. So I can do 12.5 divided by 6 multiplied by negative 4 over 1. So I do 12.5 times negative 4. I'll get 50. And on the bottom, since when you're multiplying, you can just multiply across with fractions. I'll get 50 over 6, because 6 times 1 is 6. So now what I can do is, left with this, 50 over 6, I multiply by 6 to cancel out. So I'll have 36 is equal to 50 plus b. Now that I have 50 over here, I just do subtract 50. It's kind of small right there. So minus 50 over here. I'll be left with a negative value. 36 minus 50, which is negative 14. Negative 14 is equal to b. And that's what I have so far. Now that doesn't quite make sense to me. So this doesn't make sense to me because it would make sense for negative 14 to be the y-intercept, considering negative 10 is over here and the points don't reach here. So obviously I know that there's something wrong that I did.
Sure. See if you can think about it for a minute and find it.
I think mainly my problem, if anything, is going to be somewhere around where I multiply or divide fractions, because that's one of my disadvantages when doing this.
Sure. Before you were using the calculator for the slope. Could you use the calculator in this case?
Yes. Now, I don't think a lot of people do this as much as me, because I'm someone who relies on a calculator mostly. What I do is, you have points in here. Do you mind if I erase it?
Oh, yeah, anything you want.
So I can put in here. Actually, alternatively, this is the way that I'm going to do. I'll also get the entire equation in of itself as well. Because what I'm going to do is I'm going to do a linear regression operation on this calculator. I want to make sure I have my points of 2, negative 6.5, and I also have negative 4.6. After that, I go calc, linreg. I have to make sure my list is correct, so I do L1. Oops, sorry. I do L1 here and L2 there, and I'll calculate it. It gives me a significantly different value than what I thought I had. Or it could just be because I kept this into fractions. So I'm also going to verify if that's going to be the same as my current A value in here, which is the equivalent to our M. And it says here it's going to be 2.0833. If I do negative 12.5 over 6, I get the same thing, so I know that my slope or rate of change is consistent with what the calculator says. So going off of that and going back to my linear regression, this makes a lot more sense with the y-intercept, because as I said before, even though I can eye it and say that's probably around -2, it's not exactly that, and so it's telling me that it's going to be somewhere around here, which is -2.333. So that's the y-intercept. So that means the whole equation that we would put together would be f of x is equal to -12.5 over 6. I'm just going to leave it like that because it's easier to keep into fractions. X plus b, which is in this case -2.333. The difficulty when I have at this part is I want to keep into fraction for this, but because when I use the calculator and it shows me a decimal value, I don't know how to interpret that into a fraction and keep it consistent or more accurate.
Gotcha. Okay. So you use the fraction here. You use linear regression. What is linear regression doing for you? What are you thinking about when you use linear regression?
When I use linear regression, I put in points that I know that are for sure that I'm trying to look for, and then it uses a programmed mother function in there. So in this case, f of x equals mx plus b, and then it looks for an equation that or a line that will regress or go through the points that I put in.
Okay. So it does. Is it anything related to the process that you were doing here?
Yeah, I would say so. Because it's essentially what I kind of did, where I start out with a set of points, and using those set of points, I do operations to get one part of the equation, and when I get one part of that equation, I plug that back into the mother function, and then using that information, I find for a specific variable to continue on finding out the rest of the equation.
Okay. And you said the equation. What does the equation do after you have it? What can you do with it?
Now I have this equation, which is f of x equals -12.5 over 6 x plus 2.3333 as a repeating decimal. Now I can put this into the calculator or any other machine or any other thing else, and it will draw the complete line for me that will extend even past this grid, which is past -10, -14, and so onwards. And then if I know that, I can look for any point, just like I did over here. If you want me to find a certain point, at say for example x point negative 1,000 or something, then I can go and look at it, because now it's kind of extrapolated that line beyond the boundaries of the current problem.
Okay. So you mean you could get a bigger points out here? How would you find the coordinates of this point right here?
Of this point right here? I would say there's no specification, but since it's in between 2 and 3, if you give me another x coordinate, like maybe if you specify it to be like 2.5, I can also find it.